right, so in this lesson, we are factoring special products. A couple of those special products are differences of two squares and perfect square trinomials. So we're going to start out with the easier of the two, the difference of two squares. So this is what a difference of two squares might look like, an example B and an example D. But to figure out how to factor them, it's helpful to see how they came about to be a product in the first place. So let's start with this example over here. We've got x plus 7 and x minus 7. So when you have two binomials where the first terms are basically the same and the second terms are the same but opposite signs, we call that a sum and a difference, because here you're adding, here you're subtracting. So that sum and difference is basically your two binomials that you start with, and they are your factors, binomial factors. Factors are things you multiply together. If we were multiplying them out, the first term here times the first term here, x times x would be x squared. The first term here times the last term here, so that's your outside, would be negative 7x. And then on the inside, positive 7 times x is positive 7x, and positive 7 times negative 7 is negative 49. On the inside, when we combine like terms now, a negative 7x and a positive 7x cancel each other out because it's basically going to be 0x, and 0 times anything is just 0. So we essentially end up with just a binomial x squared minus 49. So this is our product, and we call this special product a difference of two squares, or just difference of squares, because the first term is a perfect square and the second term is a perfect square, and you have a minus sign in between, which means you're subtracting, which is also called a difference. So the difference of two squares comes from the multiplying a sum and a difference together of basically the same first term, same last term, but opposite signs. All right, so now see this x squared minus 49? It looks a lot like this x squared minus 100. So if you were factoring x squared minus 49 into its two binomials, the x squared would factor into x and x. The negative 49 would factor into positive 7 and negative 7. So we have almost the exact same thing over here, x squared minus 100. So number one, you have to learn to recognize that this is a difference of two squares, or dots, DOTS, for difference of two squares. And a difference of two squares can factor very easily into two binomials. So it's very easy. It's a very easy product to factor if you remember how. And that's one of the things you need to work on, remembering how to factor these different types of things. So the x squared factors into x and x. Your 100, if you take the square root of 100, you get 10. In order to get a negative 100, one of these has to be a plus, one of these has to be a minus. It doesn't matter which one. You can have a minus first, then a plus, or a plus, then a minus, as long as the signs are different. All right, so now we have a sum and a difference, and these are your binomial factors. Okay, so hopefully that wasn't too difficult. And hopefully you remember these from integrated 2A or algebra 1, whichever you had. So now we're going to look at one that has a number in front. So if you have a number in front of the variable, the first term here times the first term here would end up giving you 16n squared. So notice that the 16 and the n squared are both perfect squares. So this whole term is a perfect square because it's 4n times 4n. On the outside, 4n times positive 5 is a positive 20n. On the inside, a negative 5 times a 4n is a negative 20n. And the last terms, the negative 5 times the positive 5 is negative 25. So once again, the middle terms will cancel out because one of them is positive, one of them is negative. So when we eliminate or cancel out those middle terms, we end up with 16n squared minus 25, which is a perfect square minus another perfect square. So we call this a difference of two squares, or just a difference of squares. But again, if we were working backwards, so if this is what we were given and we were asked to factor it into its binomial factors, you would take the square root of the 16n squared and put it as the first term in each binomial. And then you would take the square root of the 25 as the second term in each binomial. And then your signs would be different. In order to get that negative 25, the signs have to be opposite. So now here's another example that we're actually factoring. So if you recognize that this is a perfect square minus another perfect square, it's going to factor into two binomials. The square root of 9r squared is 3r. The square root of 64 is 8. And your signs have to be different, either minus plus or plus minus. And that's it. So difference of squares, super easy, but easy to forget as well. All right, so this is a couple notes I want to make here. This is what we call a difference of squares, or a difference of two squares, and these are your binomial factors. And it's a sum and a difference because we have adding and then subtracting the same two terms. All right, one other note that I would like to make before we go to the perfect square trinomials, and that is if you have a perfect square like x squared plus another perfect square. So perfect square, perfect square, but you have a plus. So if it's a sum of squares, then your answer is just, if you're asked to factor it with real numbers, you would just state that it's prime because it cannot be factored with real numbers. Now, when we get to complex numbers or imaginary numbers, then we can see that a sum of squares can be factored using imaginary numbers, but it cannot be factored using real numbers. And just to prove it to you, I'm going to just do, let's see if I have a little bit more room. I'm just going to do it off to the side here right now, but then I'm going to probably erase it for this example here. So let's just, for example, say that we tried to factor a sum of squares. And students think, oh, it can factor into x plus 5 times x plus 5. Well, in order for x plus 5 times x plus 5 to be the factors of x squared plus 25, that means that when you multiply them back together, it should equal what you start with. Well, if I take x times x, I do get the x squared. X times 5, I get positive 5x. 5 times x is also a positive 5x, so they're both positive. 5 times 5 is your positive 25. So your middle terms do not cancel out. So you do not get x squared plus 25. You get x squared plus 5. Or I'm sorry, not 5. X squared plus 10x plus 25. So this is not the same as x squared plus 25. So that's why when students try to factor the sum of squares into two binomials, it doesn't work. When you square a binomial, you get a trinomial. All right, so moving on. I'll see if I have space for that. All right. A perfect square trinomial basically means that when you factor it, it's going to factor into two binomials that are identical. So here we have an example of a basic trinomial because our a value is 1. So we can factor it, if it's factorable, we can factor it into our two binomials with parentheses. Your x squared factors into x and x, two numbers that multiply together to equal 36. So if I want to do this off to the side, multiply together to equal 36 and add up to a negative 12. Will be -6 and -6. Remember, with your signs, if your C value is positive, you have to have the same signs. But in order for that B value to be negative, they're both going to be negative. So if your signs are the same, then the B value tells you what they are going to be. So they have to both be negative in order for them to add up to a -12. So you get -6 and -6, x minus 6, x minus 6, the same two binomials. So if these are identical, so this is a little bit different than the difference of two squares, because in a difference of two squares, your signs are different. One's a minus, one's a plus. So you can't do this when you have different signs. If you have the same sign, so if these binomials are exactly the same, then you can rewrite it as x minus 6 squared. So if you see an expression that's x minus 6 squared or a binomial in parentheses squared, that means there are two of those binomials being multiplied together, which when you multiply it together would equal this trinomial that you started with. Okay, so now let's look at one that has a number in front. So your a value is not 1. So if your a value is not 1, then you're going to use that AC method that we learned about last week. So we take your a value times your c value, and you get a positive 36 again. Your b value is positive 12. So we'll figure out these numbers in just a second. I kind of skipped the first step. So the first step with AC method is to go from 3 terms to 4. The first term stays the same, the last term stays the same, and then our middle terms, sign rules still apply. If the A times C is positive, you're going to have the same signs, but this time they're both going to be plus. So they're both going to be positive 6 this time. Well, when you put the positive 6 in here in the middle, whatever this variable is has to also be part of those middle terms, because those two middle terms have to add up to 12x. Now factor by grouping. Different color, I guess purple. So to factor by grouping, separate the first two terms from the second two terms. We can factor out a 2x. So then when we divide each of these terms by 2x, we get 2x plus 3. And then from these two terms, we can factor out a positive 3. And when you divide both of those by positive 3, you get 2x plus 3 again. So now think of this as one term. Think of this as one term. They both have the 2x plus 3 in common. So you can factor it out. And then the 2x plus 3 that you had factored out earlier goes together. And again, you can see you have the exact same binomial multiplied by itself. So this can be rewritten then as 2x plus 3 squared. All right, there's one other note that I wanted to make before we end these notes. So if you are given something like x plus 8 squared, to simplify. One mistake that students typically make is they want to just square each term and call this x squared plus 64. That is going to be incorrect every single time. So when you have a binomial squared, my suggestion would be for you to rewrite it as two binomials, because x plus 8 squared means x plus 8 times itself. Then multiply it out. X times x is x squared. X times 8 is a positive 8x. 8 times x is another positive 8x. 8 times 8 is a positive 64. The middle terms do not cancel out, which means that you're going to have a middle term. So one thing that I typically will say over and over and again is the square of a binomial is a trinomial. So if you're squaring a binomial, so you have a binomial squared, it will always equal a trinomial. If you don't have three terms, then you don't have the right product. All right, so that concludes our lesson for today. Your assignment is on Math Excel.